Have you ever tried to build something but you just didn't have the right tool for the job? Maybe one tool was fast but messy, and another was neat but super slow. This is a story about a scientist who faced a similar problem but with computer programming. His name is Bjarne Stroustrup, and back in the late 1970s, he was working at a very famous place for science and invention called Bell Labs. He was a very curious person, always asking questions and trying to figure out how things worked. This curiosity is what starts every great scientific adventure, and his was no different. Dr. Stroustrup was working on a really big, complicated project. He was trying to simulate how different parts of a computer system would talk to each other. Think of it like trying to predict traffic in a big city before you build the roads. To do this, he needed a special kind of computer language. He needed a way to describe his ideas to the computer so it could run the simulation. The problem was, the tools he had weren't quite right. He found himself stuck between two choices, and neither one was perfect for what he needed to accomplish. This frustration is often the first step toward a brilliant new invention. He had one programming language that was great for organizing his ideas. It let him create models of different parts of the system, almost like building with digital Lego blocks. This made his complex ideas easy to manage and understand, but there was a huge problem. It was incredibly slow. Running his simulations took a very, very long time. Imagine waiting for hours just to see one small result. This slowness made it almost impossible to get his work done efficiently. It was like having a beautifully designed car that could only drive at a walking pace. On the other hand, he had another programming language that was the complete opposite. This language was famous for being lightning fast. It could run calculations and perform tasks with amazing speed, which was perfect for the heavy lifting his simulations required. However, this language was much harder to use for organizing big, complex ideas. It was like trying to build that same Lego model, but with all the pieces jumbled together in one giant box with no instructions. It was fast, but it was messy and difficult to manage for his specific project. He was stuck with a difficult choice: easy organization or pure speed. Let's look closer at these two languages. The first one, the organized but slow one, was called Simula. Consider it. The name itself sounds like simulate, which is exactly what Dr. Stroustrup was trying to do. Simula was amazing because it allowed programmers to think in terms of objects. An object is just a way of bundling together data, and the things you can do with that data. For example, you could create a car object that had data like its color and speed, and actions like start engine and accelerate. This made it very intuitive to model real-world things. But all that wonderful organization came at the cost of performance. The second language was the famous C programming language. C was, and still is, known for its incredible efficiency and power. It gives programmers very direct control over the computer's hardware, which is why it can run so fast. It's like being able to talk directly to the engine of your car instead of just using the pedals. This is fantastic when you need every last bit of speed. But for building large, complex systems like the one Dr. Stroustrup was working on, C didn't offer those nice object features that made Simula so easy to use for modeling. It was powerful, but primitive, like a rocket engine without a steering wheel. So, here was the big problem. Dr. Stroustrup needed the beautiful, easy-to-understand structure of Simula, but he also desperately needed the raw, unadulterated speed of C. It was a classic conflict. He could either write his program in Simula and wait forever for it to finish, or he could write it in C and struggle to keep his complex ideas from becoming a tangled mess. Most people would have just picked one and accepted its flaws. They would have compromised and just tried to make the best of a bad situation. But scientists, especially curious ones, don't like to compromise when they know there could be a better way. This is where the magic happens. A truly brilliant idea was born from this frustration. Dr. Stroustrup asked a simple but profound question. It's a question that has driven innovation for centuries. He looked at the slow, elegant Simula and the fast, powerful C, and he thought to himself, why can't I have both? Why should he have to choose between elegance and performance? Why couldn't there be a single tool that gave him the best of both worlds? This single question was the spark that would eventually light up the entire world of software development. It was time to build something new. With this powerful question in mind, Dr. Stroustrup didn't just wait for someone else to solve his problem, he decided to solve it himself. He was at Bell Labs, a place where innovation was encouraged. He started a personal project. His idea was to take the C language, which he already knew was fast and powerful, and add the features he loved from Simula. He wanted to extend C, to build upon its strong foundation. He wasn't trying to throw C away, he was trying to make it better. He called his new project C with classes. The classes part was the key idea he borrowed from Simula, allowing him to create those neat objects he needed. He began by creating a preprocessor, which was a special program that would take his new C with classes code and translate it into regular C code. This was a clever approach because it meant his new language could be used anywhere that C could be used. He was essentially building a bridge between the world of high-level, abstract ideas and the world of low-level, high-speed computation. He was adding the ability to create those car objects with their own data and actions, but in a way that could still be compiled down to super-fast machine instructions. It was a truly remarkable feat of engineering. Of course, not everyone was convinced at first. When you create something new, people are often skeptical. Some programmers who loved the simplicity of C thought his new additions made the language too complicated. They were used to their fast, simple tool and didn't see the need for these new class features. Others thought he couldn't possibly achieve the elegance of other object-oriented languages while keeping the speed of C. He faced criticism from both sides. But Dr. Stroustrup knew he had solved a real practical problem, and he kept working to improve his creation. Slowly but surely, other programmers at Bell Labs started to notice. They had similar problems. They also needed to build large, complex systems that were also fast and efficient. C with classes, which was later renamed C++, was the perfect tool for the job. It spread through word of mouth from one programmer to another because it worked. It solved a fundamental problem that many people were facing. It wasn't just a theoretical idea. It was a practical solution that made programmers' lives easier and their software better. Its success was driven by its sheer usefulness. The language Dr. Stroustrup created, C++, grew far beyond the walls of Bell Labs. It became one of the most important and influential programming languages in the world. Why? Because the problem he solved, the need for both performance and abstraction, is everywhere in technology. Think about the most demanding software you use. Modern video games, with their stunning graphics and complex physics, need to be incredibly fast. Many of them are built with C++. Your computer's operating system, whether it's Windows, macOS, or Linux, relies on C++ for its core components to run everything smoothly and efficiently. The impact of C++ doesn't stop there. When you browse the web browsers themselves, like Chrome and Firefox, use C++ to render web pages quickly. The powerful three-dimensional modeling software used to create animated movies and architectural designs is often written in C++. Even in the world of finance, high-frequency trading systems that need to make decisions in a fraction of a second are built using C++. From the software in your car to the servers that power the internet, C++ is a hidden but essential part of our modern technological world. It's the powerful engine running behind the scenes. All of this amazing technology can be traced back to one person's experience. It started with Bjarne Stroustrup's frustration and his simple, curious question, why not have both? He didn't accept the limitations of the tools he was given. Instead, he saw an opportunity to create something better. He combined the strengths of two different ideas to make a new one that was more powerful than either of its parents. This is a perfect example of how science and engineering move forward. We stand on the shoulders of giants, and then we build something new on top. So, what's the big lesson here? It's that curiosity is a superpower. When you encounter a problem, don't just get frustrated, get curious, ask questions, ask why. And what if? Dr. Stroustrup's story shows us that one person with a good question and the determination to find an answer can truly change the world. It reminds us that the next time you feel stuck with the tools you have, you might be on the verge of inventing a better one. So, go out there, be curious, ask questions, and maybe you'll build something that changes everything. Consider the following.